Okay, there are some derived forms of the conditional, and they are called the converse, the inverse, and the contrapositive. Now, they all are based on the original, let's see, I guess I'll go with that color. Your basic conditional equation is always if P, then Q. If P, then Q. Now, for the converse, it will have the form of if Q, then P. So for the converse, if they ask you to come up with the converse of the conditional equation, you will switch the statements for P and Q. So instead of if P then Q, you'll have if Q then P. They call that the converse. For the inverse, which is in green here, it has the form of if negate P, then negate Q. It's still if P then Q, but for the inverse, they negate both of them. They don't switch them. They leave it if P then Q. They just negate them. If negate P, then negate Q. And then the last one, which is the contrapositive, which is in pink, actually puts the converse and the inverse together in one problem. They switch the P and the Q. They put the Q statement before the arrow, which means they're making the conclusion the hypothesis and the hypothesis the conclusion, but they are also negating them at the same time. So the contrapositive means negate both P and Q and also switch them. Now, you do have all this information on this handout right here, which on my face-to-face classes, the students are given this in class. And the part that you're looking at for this is down here. It's this one. This shows you the converse, the inverse, and the contrapositive. And then in symbolism, it shows you. So you're starting with the original statement in the pink, if P, then Q. The converse would be if Q, then P. The inverse would be if negate P, then negate Q. And the contrapositive is if negate Q, then negate P. So you don't have to memorize them. You can use this sheet, but most of these problems will be like in words. And so I will actually do examples of those when I get to the My Math Lab portion of the show. So this PowerPoint doesn't have any actual examples. So anyway, so we'll come back to that. And then the last part of this goes over the biconditional. Now, I had talked about biconditional in section 3.1, and that's the if and only if statements. And this is when if you were to switch the hypothesis and the conclusion, you would get the same result either way. And I think the example that I used was about the triangle. You know, if you have a polygon with 3 sides, then you have a triangle. But if you switch it and said, if you have a triangle, then you have a polygon with 3 sides. It's true either way you word it. So remember that the symbol for this is this double arrow. That means it works both ways. And you'll notice that I wish there was more highlight colors in here, but there's not. You'll notice in this one that the only time you get a true result is when they're either both T's or both F's. Because if it's if true then false and you reverse it, if false then true, it's not the same thing. So the stuff in the middle, these two, would give you falses. Okay, and that is the biconditional. which I think there's an example here. Yeah, so here's a truth table. It's already done for you. Whoops. It says construct a truth table for the statement. The negation of P or Q, if and only if, the negation of Q and P. And so they went ahead and did the whole table, and they've got the numbers at the top, and you can see that they did copy column P, which is right here. They copied the column P right there. Did not mean to do that in pink. Sorry about that. Boop. You know how I copy them? They copied it right here. There's P. And then here's P and Q. Normally I would put P, which is true, true, false, false, and then Q is true, false, true, false. I usually put those there so that when I go to do the or in between, I just have to look at these two. It makes it a little easier in my brain. They didn't do that here, but so if it's an or, at least one true. So true and true is true, true and false is true, false and true is true, false and false is false. So this column here is correct, obviously. And then, so that was step one that they did right there. Didn't mean to do that. Step one, boop. And then they went and did step two, which is here. And that is the negation of what you just did in the parentheses. So to get this column, you have to look at the orange one and negate it. Since the orange one is true, 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 false, this one becomes false, 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 true. Then they went over to the second set of parentheses, and they had to do the negation of this Q right here. So that was step three. And to get this one, you just had to look at Q. Over here, it's true, false, true, false. So this becomes false, true, false, true. And of course, the black one was just copying. And then we're going to do the and right here. So that's step four. And to do this one, you just compare the two columns on either side of it. But on an and, they both have to be a true to be a true. And so the first row, false and true is false, true and true is true, false and false is false, true and false is false. So that's correct. And then the very last step, which is this one here, number 5, it is the if and only if. And to do this one, to the left of it, you have to look at the very last step, which was this pink, and compare that with the last step to the right, which was step 4. And then remember, on if and only ifs, they both have to be false or they both have to be true. So on this first one, false and false gives you a true. False and true gives you a false. False and false gives you a true. True and false gives you a false. And that's the final step on that one. Which then brings me to my math lab portion of the show. So I will stop it here and start my math labs with separate videos. Biconditional.